Was Neil deGrasse Tyson wrong about rocket launches? Let's hear what he has to say.
So, Charles, here's something amazing. You ready?
Yes. Go
The
ahead.
exact trajectory of a rocket. You know what it is? It's an exact trajectory. Do you know? I'll tell you what it is. It is the physically inverted solution to the deGrasse problem.
No kidding.
Yes.
Wow.
Yes.
So, first of all, what is the deGrasse problem? This is a well-known physics problem where we want to find the path between 2 points that takes the least amount of time to travel, when moving only due to gravity. The solution is a shape called a cycloid, and it looks something like this. Now, Neil claims that
You take that, flip it up. It is the minimum energy expenditure into orbit. Because if you go up too high first, you wasted too much energy gaining altitude. If you go downwind first, you're wasting too much energy trying to go horizontal. So it's the perfect inversion of that problem. That's why it's great.
So what's wrong with this? It all sounds very reasonable. First of all, the major flaw in logic here is that rockets don't want to take the fastest route to orbit, because that isn't very efficient. Instead of doing this, they slowly arc over and allow gravity to shape their trajectory. The problem arises from the fact that the cycloid solution only really applies to objects accelerating uniformly due to gravity. In other words, there is always a force acting directly downwards, and that force doesn't change. Now, when a rocket launches, not only does its acceleration increase as it loses mass, as it gains altitude, the gravitational force on it changes. This means that the magnitudes of the forces involved are always changing. So the question is, if the ideal launch profile isn't a cycloid, then what is it? Really, it depends on both the body you're launching from and the characteristics of your rocket. Some rockets would benefit from going straight up for longer, perhaps because their thrust-to-weight ratio is low, or because they might have high drag in the atmosphere. However, if you were launching from the moon, for example, you would want to turn horizontal as soon as possible to maximize your efficiency, which means that the optimal launch profile here obviously can't be a cycloid. So, what do you think? Was Neil deGrasse Tyson wrong or just oversimplifying? Let me know in the comments.